How spiders build mathematically perfect webs. Spider webs often look like simple threads stretched between branches. But if you look closely, something incredible appears. Perfect circles, evenly spaced lines, precise geometric patterns. It almost looks like a carefully designed engineering project. Yet spiders don't study mathematics or architecture. So how do they build webs that look so mathematically perfect? The answer lies in instinct, biology, and the remarkable properties of spider silk. Step 1. Building the first bridge. The process begins with a single thread. A spider releases a strand of silk into the air. The wind carries the thread until it attaches to another surface, maybe a branch, a wall, or a nearby plant. Once the strand sticks, the spider carefully walks across it, reinforcing the line to make it stronger. This first strand becomes the bridge line, forming the foundation of the entire web. From this point forward, every part of the web will grow outward from this initial connection. Step 2. Creating the frame. Next, the spider builds the outer structure. It moves along the bridge line and attaches additional silk threads to nearby surfaces, creating a rough, polygon-shaped frame. Think of this as the skeleton of the web. This frame must be strong enough to support the rest of the structure. Once the frame is secure, the spider adds several threads stretching from the edges toward the center. These are called radial lines, and they act like the spokes of a bicycle wheel. Step 3. Finding the center. After placing the radial lines, the spider moves toward the middle of the web. This central point will become the hub where the spider usually waits for prey. From here, the spider begins constructing temporary spiral threads that move outward. These early spirals are not sticky. They serve as scaffolding, helping the spider maintain even spacing between the radial lines. Step 4. The sticky spiral. Once the framework is complete, the spider starts weaving the final spiral. This spiral moves from the outer edges toward the center. Unlike the earlier threads, this silk is sticky. Tiny glue-like droplets along the thread help trap flying insects that collide with the web. As the spider lays this spiral, it removes the temporary scaffolding threads, replacing them with the final capture threads. To human eyes, these webs look like carefully calculated geometric designs. But spiders don't measure angles or distances. Instead, they rely on sensory feedback. Spiders use their legs to feel the tension of the silk threads and the spacing between them. This allows them to maintain consistent distances as they weave. The spider's nervous system and instincts guide every movement. Over millions of years of evolution, this behavior has become incredibly precise. Spider silk is one of the strongest natural materials on Earth. Pound for pound, it can be stronger than steel. It is also extremely flexible. This combination of strength and elasticity allows the web to absorb the impact of flying insects. When prey hits the web, the silk stretches slightly, reducing the force of the collision and keeping the structure intact. The circular shape of many spider webs is not just beautiful, it's efficient. The radial lines transmit vibrations directly to the center of the web, where the spider waits. When an insect becomes trapped, the spider instantly feels the vibrations through the threads. In seconds, the spider can rush out, wrap the insect in silk, and secure its meal. Nature's hidden engineers. Spider webs may look delicate, but they are carefully engineered survival tools. Without rulers, calculators, or blueprints, spiders construct intricate geometric traps every single day. What appears to be mathematics is actually the result of millions of years of evolution shaping instinctive behavior. And every time a spider builds a web, it quietly demonstrates one of the most elegant designs found in the natural world.